afternoon. My name is Blake James. I'll be presenting the webinar today. This webinar is going to be on integrating the FEMAP API with Python. And it is 2 o'clock, so we're going to go ahead and get started. So I want to start with a quick overview of what we'll be doing today. I'm going to start with a quick overview of SDA as a company, tell who we are and what we do. I'll then go into a quick overview of what the COM interface is, how it integrates with FEMAP and Python, and how we can use it to allow Python to work with FEMAP. I'll give a quick introduction to both Python and FEMAP. This is by no means a tutorial on how to use either one. This is just a tutorial on how to get them to work with each other. That's going to be done using the MakePy utility, which is part of the fairly standard Python installation. We're going to go over one particular hurdle that we have to overcome, which is a pass by reference issue in VBA. And there's a solution to that, which I'll go over. And then I'm going to demo how all of this works and walk through the process step by step. If you have any questions, please feel free to leave them in the questions box on the GoToWebinar interface. And the slides are available in the handout section, which is useful because some of the code snippets you'll want if you're trying to copy this. Okay, so we are SDA, also known as Structures.Aero, which is our website. We were founded in 1997 to provide expert aerospace structural analysis. We serve a variety of industries, specializing in composites with strong, lightweight structures that are readily manufacturable. We go from low-level support all the way up through full test plans and advanced stress analysis. And we typically support anything from small to large UAVs, manned and unmanned spacecraft, naval structures. We've done some commercial aircraft. Our team consists of over a dozen bachelor's, master's, and PhD level engineers. And we're located in Sterling, Virginia, which is just north of Dulles Airport. These are just a quick example of some of the projects that we support. We've done Aurora's Excalibur, the VA-1 for Vanilla, the Lockheed Constellation restoration for Lufthansa. We work with the NASA Orion Crew Module. We've worked on the heat shield for the Orion Crew Module. We're working on the first space telescope with Goddard, and a variety of other things, as you can see here. In addition, we are a Siemens Value-Added Reseller and certified provider of first-line support. We specialize with FEMAP within Nastran, but we also support Solid Edge, Fibersim, Enterprise, NX Nastran. And additionally, we are a reseller for Collier Research Corporation, which is the maker of HyperSizer, which is a structural analysis and optimization package. With that out of the way, let's go ahead and jump into how to make Python and FEMAP play nice with each other. First of all, I'm going to give a quick overview of COM, or the OLE interface. It is a language-neutral method of implementing objects between environments or between different programming languages. So this allows the transfer of information between different pieces of software, and additionally between different programming languages. So this is how FEMAP and Excel, for example, can work together in the API. Now, conveniently, both of those are using VBA. So they speak the same language, which makes it quite easy, but they are still going over the COM object to talk to each other. Python also has the ability to utilize a COM object, so we can make Python work with FEMAP or with Excel or anything else that has a COM interface. So, and the same is true because it's language neutral. Any programming language which has support for COM or OLE, which is most of them. There's very few that I'm aware of that don't have support for COM in some way or another. They can all talk to each other if you want to jump through some hoops. Python, just to give a quick overview, it's a general-purpose, high-level programming language with an emphasis on code readability. It has multiple programming paradigms. Specifically, the one that we'll be looking at is object-oriented because we are dealing with an object-based API with FEMAP. It's dynamically typed, so you don't have to declare variables or what kind of objects the variable will hold. It has automatic memory management and a very large package library. I listed some of the more useful ones for general engineering applications, and things like NumPy or SciPy or the matplot library. These can be very useful if you're trying to develop things for engineering purposes, and then what we'll go over is how to get information in and out of FEMAP if you want to utilize some of those libraries. So the FEMAP API, I assume everyone is familiar with, but it is an OLE or COM-based programming interface. It has native support for Visual Basic .NET and VBA, as that's how it's written. And if you read in the FEMAP API manual, it also lists support for C and C++. And I'll give you a quick example of that. So in VBA or .NET, where we do a dim FEMAP as object, and then a get object on a FEMAP.model, right? This is a very quick code segment, which is just going to connect to an open FEMAP session and close it. So it takes 3 lines. It's very simple. If you want to do the exact same thing over the COM interface in C or C++, it looks like this. So this is a very low-level set of code dealing with creating and utilizing that COM object to its very end call the FE file exit function. Yeah, I don't know about you. I don't want to be dealing with that. So how do we do this in Python? Well, we can do it in a similar setup to C. We can manually deal with the COM interface. We can create it. We can work with it, send commands. It's possible, but it's a pain. Conveniently, Python has a very wonderful program called MakePy as part of one of its packages. And what this does is it allows you to point at an existing type library, specifically the FEMAP type library and the default FEMAP install directory, and convert that into an importable Python object. So I do want to note that this is not part of Python directly. It's part of the Win32com package. Depends on where you got Python from. Sometimes it's installed by default, sometimes it's not, but it can be found with the Python for Windows extension, and you can just Google that. It should come up. So this piece of code here is the important one to get started today. This can be run through this code. You can also look at what this is doing and run it command line if you like, but this just gives me a simple way to run it directly. So this code, first of all, imports the MakePy function out of the Win32 object. We then set some argument variables. We're going to do MakePy with an output of what I'm calling pyfemap.py. So this is the FEMAP file we're going to convert the type library into. Sorry, the Python file we're going to convert the type library into. And then we need to point it to the type library. And please note that the R in front of that, if you're not super familiar with Python, that's not a typo. That is just saying this is a raw string, so we don't have to escape any of the backslashes and things like that. Makes it easier to type a directory, or in this case, a file with path, much easier. And then we're going to tell MakePy to run. So what this is going to do is it's going to give us a way to utilize the FEMAP API directly in Python. So on the left, we have the same code we looked at before, right, where we're declaring an object and then calling the FE file exit. On the right, after we have imported this new pyfemap file, we can do basically the same thing. The first line goes and finds that object of the running FEMAP session. The second line is connecting to it, and we are telling it that this is a pyfemap.model. So we're kind of giving it the object and where to go find it. Once it has that, it works exactly the same as the code on the left. In fact, even most of the formatting is the same, right? So in this case, we can just call femap.fe file exit. So those two sets of codes will do the exact same thing, one in VBA, one in Python. So there's one issue with this, and that is pass by reference. So when we're operating over to a COM interface with Python, the pass by reference is not available to us. This is due to the way COM works, but this by reference function or ability is used in many of the FEMAP API calls, where the output variables are passed into functions as inputs, and And because they're by reference, the function can just modify those directly. So I have an example of one, which is just the get column out of a results browser object. You pass this function 3 different inputs. One is actually an input, and it's what column you want to grab. The other 2, you need to declare the variables and then pass it to this function, just empty, and this function will populate them. Right? So it'll populate the IDs and the result values for whatever you've requested. So this is a problem because we can't do by reference function calls. There's a way around it though, thanks to MakePy. And what it does is it rearranges the functions. So in this case, for the VBA or VB.NET, right, that's how our function call would normally look for this. We're receiving the return code, but we're passing it 3 variables. The number column index is our input, and the IDs and the values are both outputs. So when we write this in Python, it gets reordered. Python does have the ability to return multiple outputs from a function, and that's what we're doing here. So we've taken those output variables, the IDs and the values, and we've actually put them on the left side of the equals, just returning all of the outputs as a set. Thing to note here is the first one. If a function has a return code, it is always the first piece of data returned. So don't forget that. If I just put IDs and devals and forgot the RC, or the return code, then the IDs variable would be the return code, the devals variable would be the IDs, and we would never actually store the devals. But in general, depending on how you've got Python set up, that will not create an error. You don't have to capture all the outputs. So something to watch out for. So let's do a quick demo of how this works. So the first thing I'm going to do is I'm going to pull up just my general Python directory, wherever you happen to have it installed. And then this is the file that we will need to create. For the interest of typing errors, I already have it. So this is that exact same code that is in the PowerPoint. So you can grab the PowerPoint if you need to download it. And what this is going to do is, again, run that MakePy function, and it's going to generate that pyfemap.py file. So if we go ahead and run this, this is what we got. And in that same folder, you'll see this pyfemap.py showed up. So if we open that up, this is a very long file, and it is essentially the type library and all of the functions contained therein converted over into FEMAP. So there's some useful things to note here. First of all of the constants have been copied over, and I'll show you how to get to those inside of Python. And then you can see all of the different classes that exist inside of the FEMAP API have been converted over into Python. So this is very useful if you want to look at an analysis study. You can see all of the methods here. You can see the order of the inputs. This should all match what is happening in the FEMAP API. The thing to note is the returns are going to be slightly different, so you can actually look here to see the order and how many returns are coming out of it, where the functions have gotten slightly rearranged. So I will note the order should match. They're just on the other side. They're outputs instead of inputs. So how do we utilize this? First of all, we need to take this file, and you need to put it somewhere that is on your Python path so your code can find it. So I'm just going to put it in the library folder here, because I know that's by default on the path. And then we're going to run an example real quick. So the example I'm going to run is fairly simple. We are dealing with this FEMAP model, which is just a simple plate with pressure, but it does have results, which is what we're going to be looking at. And then this is the code. So at the top, we first need to import Python com, because we'll need that to deal with the com object, and then we import pyfemap, and this is the file that we just created in the last step. And then specifically, I'm going to import the constants from that. You don't have to do this. This just saves on typing a little bit. You could do pyfemap.constants. Whatever you need. And then I'm going to import sys just for this code. And first, I'm going to try and actually connect to FEMAP. So I'm going to declare an existing object, python com.connect, And then this comes straight out of the PyFemap file that we just created. It's pulling the CLS ID, which is connecting to the COM object as PyFemap has already defined it. And then we're going to do app equals pyfemap.model existing object. So this is our connection to FEMAP from Python. Then I have an except clause. If for some reason FEMAP isn't open, it's just going to stop. From this point on, it's fairly similar, if not almost identical, to how the VBA code will work inside of FEMAP. Of course, with Python syntax and that kind of thing. So we're going to start. We're just going to do an app message. I could put the constant here for the FCM normal, and I'll show you that in just a second. But in this case, I just type manually, do 0, pass the string that we want to write. And do notice I'm capturing the return code just as we go through here. And the wonders of Python, I don't have to declare what type of variable RC is. It will just figure it out because it's dynamically typed. I'm going to do the same thing here with a results browsing object, just app.fe results, right? That object is now set, it's created, and it's ready to go. Unlike VBA, where this is a two-step process where you first have to dim the object and then set the type of the object. The two steps are not necessary in Python. So I'm going to pull an output set, just whatever active output set there is in FEMAP, and this is where we're using the constants function. Right, so up here instead of 0, I could have done constants.fcm normal. Either one works. So we're going to print something. This is actually printing to the Python output, not into FEMAP. We're going to declare a node set and do an add all. So you'll see this works the exact same way that VBA does. So we're going to add all of the nodes in the model into this set. Then we're going to work with our results browser object. We're going to add a column from that output set. We're just going to add column 1. We're grabbing total displacement. And notice there would normally be more inputs to this function, but in this case, the number of columns and the column indices that it added have been moved to the left because the order has changed since we can't do a pass by reference. We're going to set the data that we need from that node set ID, and we're going to populate it. So all of this works exactly the same way as it would previously. We're then going to do the get column. Again, this has been reordered. And then just in Python, I'm going to go through and print all of that output and then run the app message here. So if we run this code, you will see what it's done is it's gone through the active output set and taken the displacement for every node and spat it out to Python. So once you have it in the arrays here in Python for the ID and the values, you could do whatever you want with it. You can use it through NumPy, you can native Python code, whatever you need to be able to do it with, it's in Python. So we're going to do one more quick example. Again, a very similar set of code. We're going to connect to the Python object just as we did before. This time we're going to declare an element, declare a set, and then add all of the elements in the model to that set. And then here we're doing a while loop, just like we would in VBA. We do a reset just to be safe. It's not necessary in this case. But then we're going to do while element set.next. We're going to get the current ID every iteration through the loop. And then I'm just printing out the property ID, which is very boring in this model because they're all 1. But if we run this, it prints out a bunch of 1s to FEMAP. So hopefully that gives a good overview of how you can connect Python and FEMAP. This obviously can go much further, but once you've got it to this point, the code is very similar. If you're familiar with the FEMAP API and you're familiar with Python, you should theoretically be off to the races. And of course, if you're not, feel free to contact us. We do have some additional resources here. One of our engineers, by the name of Eric Gustafson, has written a book called Learning FEMAP. So very helpful. It's not a Bible, but it is a very good resource for how to do all kinds of things in FEMAP, including programming. It doesn't cover Python, but it does cover the FEMAP API itself fairly well. And then additionally, if you need to contact us, again, my name is Blake Jeans. I'm a stress analyst here at SDA. My email is blake@structures.aero. And you can see the phone number down there. That's actually our support number. So if you have any questions for any of this, feel free to call. Or you can call Marty Civic, who's our Director of Sales. That's his contact information. If you have any questions, please feel free to type them in. I'll do my best to answer them. And hopefully this has been beneficial. Again, the PowerPoint is available in the handout section, and it does have that starter code for how to create the PyFEMAP file. And if you would like the code from my examples, please just contact us. I'd be happy to send that. I'll pull one of them up here in case you'd like to reference it. And that will conclude our presentation today. So if you have any questions, again, just let us know, and have a nice day. All right, so we do have one question here on what's the best place to find documentation on the classes and methods. Honestly, the best place to find the documentation is still the FEMAP API PDF file. The functions, the classes, the methods, it's all identical. The formatting is identical. The only thing that's changed is anytime you have an output, you have to move it over to the other side of the equals and pull things back to set like this. If you're looking for specifics on exactly how the Python stuff is formatted and what, if there are any differences, what you want to look at is, whoops, where'd it go? You want to look at this PyFEMAP file. So for example, we'll look for the add column. Right, that's for a data table. So there's results, add column. You can see the inputs here, the set ID, the vector ID, component corners, and then here you'll see the returns. Right, so you'll see the columns added and the column indices. So it's either the FEMAP API reference is the best place, and then from that you can interpret how it would be reformatted into Python. If you have any specific questions, then you can reference the PyFEMAP file. The PowerPoint presentation should be available in the GoToWebinar interface. There should be a handouts tab, or I'm not sure what you call it, a handouts section, where you can download that. If you're not seeing it, I think there's a view menu up top where you can turn it back on if for some reason it's turned off. Okay, that's going to conclude this for the day. If you have any questions, please just email our support email, which is support@structures.aero, or you can email me directly at blake@structures.aero. I'd be happy to help you out. Thanks.